In this problem, we are asked whether or not a reaction occurs when we combine aqueous solutions of ammonium carbonate with cobalt 2 sulfate. And what I tell students to do before you start writing formulas is look at your products and decide whether either of them forms an insoluble solid. What's going to happen in these reactions is that the cation from one salt will combine with the anion of the other salt, and vice versa. The cation from the second salt is going to combine with the anion of the first salt. So then we have to ask ourselves, okay, for that first compound that we form, ammonium sulfate, is it soluble or insoluble? Thinking about our solubility rules and the NAG-SAG, easy way to remember them. Remember with NAG-SAG that ammonium salts are always soluble, no exceptions. So ammonium carbonate as well as ammonium sulfate, those are both soluble. So the product ammonium sulfate is a soluble aqueous product, and therefore it's not a precipitate. So that one will not be the product of a precipitation reaction. Let's look at the second product, cobalt carbonate. Okay, so carbonate is not one of those ions that's always soluble. In fact, it's an ion that always forms insoluble salts. Carbonates are always insoluble, with the exception of the group 1 carbonates and the ammonium carbonates. Cobalt 2, if you look at your periodic table, is a transition metal ion. It's in group 9 in the transition metals. So cobalt is not a group 1 or ammonium soluble exception. Therefore, cobalt 2 carbonate is going to be an insoluble product. Okay, so that one is insoluble. Now we need to figure out the formula for that compound. And so firstly, the answer to the question is yes, a reaction does occur. We do form an insoluble solid, and the insoluble solid is cobalt 2 carbonate. Now we will write the net ionic equation for that reaction. So cobalt with a Roman numeral 2 means that it's positive 2. Carbonate, one of the polyatomic ions, has the formula CO3, negative 2. And so when you look at those charges, they are equal and opposite, and therefore we do not need any additional subscripts. Since it's an insoluble product, the state of matter is going to be solid. It's the product of the precipitation reaction. Just like in example 6.5 that we did earlier, when you're writing these precipitation net ionic equations, you'll put the constituent ions as ions dissolved in water on the left side. So cobalt has a positive 2 charge, and it's aqueous, and it's reacting with carbonate that has a negative 2 charge, also in solution. And of course, in your final formula, the charges will not be there. They're just there to help you figure out what your subscripts are going to be. In summary, we looked at the combination of the first cation with the second anion, the second cation with the first anion, and what we found was we did get an insoluble precipitate, the cobalt 2 carbonate. And so we wrote the formula for cobalt 2 carbonate as the product of that precipitation reaction, and then we did the reactants as ions dissolved in water or aqueous.